Hi everyone. So I'm going to introduce Hopper, which is Argent's solution to privacy. It's a trustless mixer that works well on mobile and on the web. So why did Argent need a mixer? So for those who don't know, Argent basically offers a smart contract wallet to every user, and we give an ENS, a unique ENS for this smart wallet, and then your mobile phone is essentially the remote control to that smart wallet. So this smart wallet really represents your identity. So obviously when you will start using dApps, it will be from that smart wallet, and people will be able to see, well, not only that you're using dApps from that identity, but they will also see if they want all the funds that you've transferred, they'll see the origin of those funds. So for us, it's very important, I mean, generally important in Ethereum, but I think in Argent in particular, to really break the link between your identity, in our case, the Argent wallet, and then your source of fund. Let's say maybe your hardware wallet in which you hold most of the fund. Maybe you top up Argent just from time to time when you interact with some dApps. So we need a solution that can break this link. Obviously, the Argent contracts are non-custodial, so we want a solution that is also non-custodial. We looked at different solutions out there, a number of them, such as most recently HiSwap, but I believe also Sherlock, typically work on a batch of users. You have to collect a certain number of users, let's say 10 users, and then when you have these 10 users, you can, in one go, perform a private transfers for all these users. But that means that the anonymity set is sort of bound to the number of users you have in a batch. And so we were looking ideally at a solution where if I use the mixer today, and let's say I keep my deposit in the mixer, maybe I can contribute positively to the anonymity set of users in 3 months, 6 months. So ideally, the anonymity set is closer to the set of all users of the system. And then, since we have a mobile app, we needed this system to be running efficiently on mobile, but also on web, even though we don't have a web interface. The idea is that the more lightweight the prover would be, the more clients can be built, and so essentially more people would use it, so larger anonymity set for everyone. And for the same reason, the gas cost needs to be low, because if it's very expensive, no one will use it, and again, the anonymity set will not be great. And so for looking at all these criteria, we found that Miximus was the best base for us, so we based Hopper on that, and in particular we based it on zkSNARK's Miximus, which was made by Harry, who is somewhere, I believe, there. And so Miximus indeed breaks the link between accounts and has this property that it doesn't work on batches, so you can send a note to the mixer, and then presumably if you decide to leave it there for a long time, this can help the anonymity of future users. And it has also the latest implementation is quite lightweight, both in terms of gas and in terms of computational efficiency of the prover. So how does Hopper work? So basically there are 2 steps. You send 1 ETH to the mixer, you wait, and then later on you withdraw that deposit by proving that you previously had sent 1 ETH, and that you also knew that you know the secret that was published at the same time as you send this 1 ETH. So the first step is you take the mobile app, and we have an iOS prototype that works on mainnet and on Ropsten, but it's not audited, trusted setup hasn't been done, so be very careful when you use it, but it's there in case you feel brave. So you use the app generates a random secret, you can enter the address that you want to send the funds to, these 2 things will be hashed, and that will give you the leaf hash. And the next step is you take, let's say you want to top up your Argent wallet with your hardware wallet. So then you take this leaf that the app generated for you, and you send 1 Ether to the mixer along with this leaf as data. The mixer contract will then record your deposit into a Merkle tree. Other users will do the same. Hopefully, they will all send 1 ETH to the mixer. if you wait long enough, well, the contract will be filled with lots of deposits of different users, each representing a different destination address. And when you're satisfied that you have waited enough that you are going to have a high degree of anonymity, you can then take the iPhone app again, you tap withdraw in the app, and the app will generate for you a zero knowledge proof that you know the secret behind the leaf that you previously sent to the contract. So this proof gets sent to a relayer, and the relayer submits the proof to the contract. So now the proof can verify, the contract can verify the proof, sees that indeed you know the secret behind one of the leaves, so you're entitled to withdrawing your deposit, and now you receive your deposit. So let's look at the circuit that is used for the zk proof. So basically two statements. The first one claims that you know the secret behind the leaf in the Merkle tree, and you know a Merkle path and the index of that leaf, and that this match the root, and the root is known publicly. It's a public parameter of the contract. And then the second statement involves a nullifier, which is really like a serial number that uniquely identifies your withdrawal and makes sure that you won't be able to double spend or to double withdraw your deposit. So a number of, obviously the secret and the exact leaf that you're withdrawing from are secret inputs, so they won't be sent or visible on chain. These are something that the proof proves that you know these secrets, but will not share them. And then the other variables are public inputs, which are so destination address and nullifier you provide at the moment of withdrawing your deposit, and then the Merkle root is known publicly by the contract. So these two statements, in terms of SNARK, they will be converted into R1CS, and what you really want, in order to get some, in order to make the proof generation efficient on mobile, you want this R1CS system to result in as little constraints as possible. And the bulk of the constraints will come from this Merkle verify, which is essentially computes hashes at every level of the Merkle tree. So you really want to have a hash function that is sort of friendly to the SNARK. And for this reason we used MIMC, so maybe Merkle trees maybe sometimes often use SHA-256, but we use sort of a more fancy hashing function. And so MIMC stands for minimal multiplicative complexity, and multiplication is really what you pay for in this system. So the leaf is your deposit. So it's the hash of your secrets and the destination address.
What's the leaf index?
Sorry, leaf index. It's just the index of your leaf within the tree.
Address in the tree.
Yeah, it's like the address of the leaf. Yeah.
I've been wondering for a year what that stands for. So thank you.
Welcome. Right. So thanks to MIMC, you get less constraints in your system, so the generation of the proof is faster. But then the drawback is MIMC is a lot less efficient on the EVM than SHA-256 is. So it actually costs quite a bit to perform a deposit, because when you will perform this deposit, the smart contract will update the tree on chain. So for every level of your tree, you will have to compute MIMC at least once, and so that results in a somewhat expensive deposit. The deposit in the current prototype costs about 1 million gas, and that's for a Merkle tree of size with 15 levels. And 15 levels means we can store up to 2 to the 15, so about 32,000 deposits. After which you need to redeploy a new contract. So there is kind of a trade-off here between the capacity of the tree and how expensive the deposit will be. And then another drawback is actually perhaps even more important, is that MIMC is fairly, I mean, it's clearly not as academically researched as, let's say, SHA-256. So you kind of trust that we won't find in the future some way to say find a pre-image of a MIMC hash, for example. But to mitigate that particular point, we still use SHA-256 in the leaves. So that means that actually, even if MIMC turns out to be to not be pre-image resistant, as long as this kind of construction, MIMC, where you fix the right-hand byte of the input, as long as that is pre-image resistant, then your system will be secure. And one way to see that is you can take this tree as an example. So the root is known; it's public input. We assume that MIMC can be, let's say, that the pre-image resistance of MIMC can be reversed. So we can find, let's say, a hash 5 and hash 6. And then let's say also that you've constructed a leaf of which you know the secret. So now your challenge is to figure out what should be hash number 3 so that you can reconstruct the Merkle path. And that's not going to be easy if that particular construction is pre-image resistant. So the hope is that it's a little bit more hard to crack the pre-image resistance of that thing rather than of MIMC. But I mean, obviously this needs to be proven, and it's really just an assumption.
Okay, what is C?
It's just a constant. It just means like the right-hand side of the, basically, it doesn't have to be the right-hand side. It's just like, let's say, one of the leaves, one of the two inputs being known. So I talked about nullifiers, so we use them. So when the relayer really submits the proof to the contract, so the transaction has to include a nullifier, and the contract will verify that, well, this nullifier hasn't been used before, and that the proof actually also, the second equation of the proof shows that the nullifier was derived from the secret. And if these two conditions are met, then the contract will store that nullifier so that it can check in the future that no one else will use the same nullifier. We use relayers for withdrawals, and the reason for that is that with relayers you can then withdraw to an account that hasn't been, that doesn't contain any ether, because if you had to top up your withdrawal account prior to withdrawing, then just by the fact of topping up this account, you will break your anonymity. But the relayer, so in the current prototype, we use Argent's relayer. So it's a sort of a centralized thing. The relayer just gets refunded the gas that it spends. But obviously, ultimately, we want to use a decentralized approach to that. So. Because using relayers, using a relayer introduces a number of drawbacks. So you have to trust that your relayer doesn't log IP, which would break your anonymity. You have to trust that it will actually relay your transaction. So ideally, we want to make sure that all of so for the, let's say for this the relayer not logging your IP thing, it would be great if at least some clients used some built-in, let's say, Tor routing or something like that to protect yourself from your IP being recorded. And then for the other aspects of guaranteeing sort of the reliability of the service, we want maybe a sort of decentralized registry of relayer where you have competing relayers that you can pick from. Maybe something a little bit similar to what to the gas station network from Tabuki, but that's definitely an open question and something that's being discussed. There is actually a Telegram channel that was last week, I believe, was just created just to discuss this particular question. Another question that's open and quite interesting is when do we actually when should we encourage users to withdraw? So currently, the user is free to withdraw whenever he wants, but of course, if he deposits and then 10 minutes later he withdraws and no one else used the mixer in the meantime, it's very easy to say, okay, this deposit and this withdrawal are made by the same user. Currently in the prototype, we display the number of subsequent deposits. So after I deposit, how many other people have used the mixer? It kind of gives you a rough sense of the degree of anonymity that you would get if you were to withdraw at any given time. But of course, this can easily be but it's very unreliable. Like I could flood the network, the mixer with fake transfers, fooling you into thinking that, oh great, the mixer is being used a lot, I'm going to have a high degree of anonymity, but in fact I'm the only one using it and I can immediately know that you're the one who withdrew. So it's very imperfect. One idea that is probably going to be integrated in the next version of Hopper is to say, that kind of mitigates this kind of spam attack, is to say, well, regardless of when you did the deposit, the UI, the contract will still let you withdraw whenever you want, but the UI will let you withdraw only on the next day at a fixed time. So that may be something that mitigates a little bit this type of attack. But again, that's an open question. The transfers are, so currently in the current version of Hopper, you can only transfer one ETH in, one ETH out. We could deploy multiple contracts for, sorry, I didn't see your...
Sorry, I'm curious, hi, my name's Ben, I'm the
Hi.
Director of Compliance. I'm curious why Arjun has put a mixer in their wallet natively, because mixers have got a pretty bad reputation in the marketplace in terms of doing illicit activity, like market abuse.
I think that's actually false, actually. I don't think it's fair to say that. Like, fungibility is very important, and I don't think it's okay to spread FUD like that, that there's illicit activities. Yeah.
So, whether it's true or not, they do have a reputation, don't they?
Well, I don't think they do. I think that's just false. I think people like you spread this around. That's false.
Okay. I'm curious what engagement you've had with regulatory bodies or other types of people like Chainalysis or Elliptic, or have you spoken to them?
No. So I mean, to be clear, this is the very early stage of some sort of proof of concept mixer. The mixer hasn't been used much to date. I mean, I do believe that there are plenty of use cases why you would want to use a mixer. I mean, ultimately, the mixer is, you're always free not to use the mixer, right?
I mean, don't get me wrong, I think privacy is really important. Privacy is something we should be striving for in terms of Ethereum. And it's, I think, dispelling the notion of this FUD and what it actually means to various different players. But it's a difficult line without having kind of a very transparent kind of open approach.
I'm sorry to intrude again, but I feel like this would be the equivalent to you saying Tor is just bad because Tor is only used for illicit activity, and that's not necessarily true. That's just a false narrative that people push for different reasons. So I don't think that's true. I just think it's false. Most of the people who use these things, they don't have anything against mixers. They don't. Only people who don't know what they're talking about and look from the outside and say like, oh, only if you have something bad, you must be hiding, right? But that's just not true. I'm sorry. I think it's okay if we push this forward.
Tor was developed by the US Navy to communicate between the armed forces, right?
So if I'm using Tor, I don't think I'm a criminal.
We know the best way to...
That's what you're saying, though.
Inside.
Right, so then why are you against privacy? Because why you associate privacy with illicit activities then?
So I'm not...
I'm sorry, I didn't mean to sidetrack this, I'm really sorry, but I felt like, yeah.
Yeah, I mean, to me, it's like if you think about the current state of Ethereum, currently using a dApp from a wallet like Argent, where your identity, or you can choose, you can pick your name as an ENS, so your identity is clearly visible. It's a little bit like you go use Twitter, and then whenever you check the bio of some user, you can actually see exactly how much they have in their bank account. So I mean, I do think there is value to obfuscate, well, at the very least, like your source of funds. Now you can argue whether certainly there is pro and cons about obfuscating absolutely everything, and there's also advantage to transparency. But I mean, again,
I agree with you. I think privacy is really important. It's definitely something we should be working on. What I worry about is the reaction that it gets when you start talking about it, and the education that's needed coming up the chain into various different governments.
Yeah, and one challenge also is, which I mean I have no answer for, is these mixers are deployed at a fixed address. Once they're in use, you could you could start marking an address as having passed through a mixer. And so there is a question of, maybe the ether going through a mixer will be deemed less valuable for that reason. In the same way, I believe like Coinbase now rejects deposits that are known to have gone through some mixers. So there are also, I do recognize that there are some challenges there as well as to how this will live in the broader ecosystem. Okay, so so in the current version of Hopper, we have to transfer 1 Ether in and get 1 Ether out. We could potentially deploy multiple contracts, let's say one contract for 1 Ether, 1 contract for 10 ETH, and so on. But then an obvious drawback is you then split your anonymity set across different mixers. So perhaps a better approach would be to sort of introduce a joint split circuit to the contract, where you can now maybe deposit any multiple of 1 ETH and withdraw. Well, you would still want to limit the withdrawal within a certain list of possibilities, because otherwise, again, if you're the only one to send. Because, oh, by the way, I didn't say that, but fundamentally the reason to limit to force deposits to be of a certain denomination is just because if you are the only person to send 1.52 worth of ETH and then to withdraw it even, let's say, 6 months later, just by the specificity of the amount you can be de-anonymized. So that's really the reason. So you would still want to limit withdrawals into some, maybe in a list of authorized denominations, but then you can perhaps allow, as I said, joint split circuits. So maybe you could pick any 2 leaves of which you know the secret, nullify them, and then replace them by 2 new leaves. One of them might be of value 0, and the other might be, or one of them might be, let's say 10 ETH, and then the other would be the change of whatever you deposited. So that's also something that we will spend some time for the next version of Hopper. I think some of the things we're going to research, and then so some optimization. I mean, again, this is very much proof of concept. There are a lot of optimization. So in terms of gas, so there's some low-hanging fruit optimization that can be done. Like currently, we pass three public input to the SNARK. We could hash this and make it just one, so the verification gets cheaper. There probably are ways to optimize the Solidity code to make deposit more efficient, so that we can more gas efficient, so we can maybe use a larger tree, or for the same Merkle tree size, spend less gas. There must be ways to batch deposit and withdrawals to make some savings. And then, like many projects in the space, we would hugely benefit from proposals like EIP 1108, which suggests to reduce the cost of elliptic curve operators. And then specifically here, because MIMC is really the bulk of the cost, if we had some precompile for this kind of more fancy hash function, that would be very helpful. In terms of functionalities, so again, there's some low-hanging fruit. Like currently, we store only at any point 1 root in the contract. So that means that if someone does a deposit and in the same block someone else does a withdrawal, the withdrawal will fail. So we could instead store a buffer of the last roots. There are ways to, currently the withdrawal address is decided at the time of deposit, but we could make this more flexible and let this be set at the time of withdrawal. And I already talked about allowing custom withdrawals and this decentralized registry of relayers. And to conclude, so this is very much, we want this to be a sort of community-driven project. I think it's very important that ultimately we converge on a single mixer design. It's fine in the short term to experiment with different design, but ultimately we don't want to split our anonymity set across 5 competing projects. So whether it's Hopper, whether there's a big Telegram group discussing Semaphore. So regardless of the exact project in there, I think it would be great to use one unified set of contracts and then perhaps various clients, various UI on top of that. Speaking of UI, so there is currently, so now there is an iOS prototype, as I mentioned, but now we have Also, web UI being developed by BlockX. That's a work that is funded by Moloch DAO. So as far as I know, they basically compile the C++ prover to WASM. And then way further down the line, when we'll have the contracts will be set, we'll have converged on the design, then we'll have to think about multi-party computation ceremony to take care of the trusted setup. That's it. Well, thank you very much. And again, as I said, if you would like to contribute, please do get in touch. That's really the reason why Hopper exists, is to build something that is used by the entire community.